Okay, in this presentation we're going to look at a very commonly encountered type of counting problem. Okay, so a team of 5 people is required to perform a particular task, and we have 7 women and 3 men to choose from. So let's just sort of gather up all the important details there. So we have 5 people that we have to choose, and we have a group of 10 people that we have to choose from. So that's an important detail there, that there's 10 people. Okay. So how many selections are there altogether? So this is where knowledge of binomial coefficients comes into play. Okay. So this is very important, binomial coefficients, because I'm not going to actually look at how to calculate them there, but they're exactly for this purpose. So it is 10 choose 5, or also using the other notation, 10 choose 5. Okay. And that would evaluate to 252. Okay, so there are 252 ways of selecting 5 people from 10. Now, if this notation here is just an alternative to this notation here, but ultimately they both should evaluate to 252. Okay, so that's the important thing there. Now, if you're not sure where that comes from, it's time to go over binomial coefficients and come back to this. Okay, so I'm going to use binomial coefficients a lot in this exercise and things like the multiplication rule, but I'm not going to go over them. So this is an application of them, but I'm not going to go over them. Okay, now if one of the women is an expert and must be on the team, well, you have to think about this. So somebody is going to get picked automatically. So essentially what we're doing is just picking 4 other people to go on the team as well. And that means 4 from the other 9. So it's just actually an adjustment of the question. We are picking 9 people from 4 people from 9. Okay, so from the other 9, just pick 4. Okay, and again, just using the other notation, just in case you're more comfortable with that, that is 126 ways. Okay, so one of the women must be selected. So essentially, it's just picking 4 other people from the remaining 9. Okay. So the next exercise is, if 2 people in the group do not get along and can't be in the team together, how many ways are there of selecting a team of 5? So let's call them A and B. And now we have 4 scenarios that we're going to talk about here. So we can have A only, we could have B only, as B only and not A. We could have neither. Now, what also could happen is, now let's just sort of include this for the time being, that we have both A and B. Now, we'll draw a little red line under it just to sort of say this is what we're not supposed to be included, but just sort of factor it in for the time being. Okay, so if A only, that means we have 8 other people to choose from. We can't count B, and what we have to do is choose 4 people, because we have A selected already. We need 4 more people. There's only 8 people to choose from, now that B is excluded. So 8 choose 4, that is 70. Okay, now B only, similar, actually the identical calculation, 8 choose 4, choose 70. Now it could be the situation that neither get counted. This is what you have to think about. So we have 8 people choosing and choose 5, okay, and that is actually 56. So if we add all of those up together, we should get 196. So that means that there's 196 ways such that we do not have A and B together. But let's just look at both. Okay, A and B both get selected. Okay, that means they are 3 more positions from the remaining 8 people. Okay, if we tot that up, we should get 56. Okay, now just remember, this is the complement, okay? This is the complement of what is above, okay? And that means there's no other scenario here. So essentially, the alternative approach, other approach, would be to just pick 252, or select, use this approach, 252 ways altogether, and subtract the number of ways that we cannot use, and that would have yielded us 196 also. Much quicker approach there, okay? So just to highlight this fact, that if you can get into the habit of using the complements, or thinking about what is the complement event, you might be saving yourself a lot of work in the long run. So the next question is, I'll give myself loads of space for that one, okay? So if the group must contain 3 women and 2 men, okay, precisely 3 women and 2 men. So that means it is, we're going to we have 7 women to choose from altogether and 3 men, okay? So essentially what we're going to do here is pick out 2 subgroups. So essentially, we're going to pick from 7 women, we're going to pick 3, okay? And we're going to multiply that by all the ways we can pick 3 men, or 2 men from 3, a group of 3, okay? So this is using the multiplication rule, which is a very, very important approach. So 7 choose 3, that is equal to 35 times 3, and that is equal to 105 ways, okay? So the key thing here is the multiplication rule. Sorry, I just give myself a bit of space there. Multiplication rule. Oops. Very, very important. Now, finally, if there must, sorry, not finally, nearly finally, if the group must contain more women than men, okay. Now, that means 3 women, 4 women, and 5 women. But it does not contain, so let's just think through it, 2 women, that means 3 men. Or what about 1 woman? Okay, whoops. So in that case, 1 woman, 4 men. Hang on, we can't have that because we've only got 3 men to choose from. So we can't use, that's not a scenario that we're going to use. So this is the complement rule in action again, okay? So essentially, this is equivalent to asking, how many ways are there of picking 3 men and 2 women? So this is actually if you start thinking about it, and again, the complement rule, start thinking about what you need to do here. What I'm going to do is calculate this and use the complement rule. So we have, from 7 women, choose 2. And from 3 men, choose 3. That is equal to 21 times 1, which is 21. And that gives us, that means that the complement of that, which is that there are more women than men, would be 231. Okay? So again, the key thing there is the complement rule. Okay, always think about set complements and all that. Okay, always very useful, very good habit to get into. Now, the last question is, what if there are more men than women? Well, actually, I've answered this already. See part 4, or sorry, part E. There are 31 ways. Okay, sorry, not 31, 21. Let's just fix that there. 21 ways out of 252. So that's grand. We'll leave that there.